Good afternoon. I'm really pleased and honored to be part of this discussion today. I'm especially excited to moderate our next panel after that inspiring conversation with Mariana Mazzucato and Tom Khalil. Now we're going to dig into some really critical technologies, advanced systems. By that we mean advanced different computing technologies, including AI, quantum, computing, and automation and robotics. And we're going to ask, how do we use these technologies to solve and address really big problems? And how do we scale up and commercialize these technologies? We have two amazing people here with us today. Alán Aspuru-Guzik is a professor of chemistry and computer science at the University of Toronto. But that doesn't begin to touch on all the things he does, including his involvement with the Vector Institute in Toronto, one of the world's leading centers of AI. His research is revolutionizing the fields of chemistry and material science as he uses AI and quantum chemistry and automation in his lab. He has also founded two really interesting companies, Zapata Computing, which uses quantum computing, which works on quantum computing software, and Robotics, which uses AI and robotics for material discovery. Laura Major is a CTO at Motional, a really interesting company working on driverless car technology. She's an expert in machine learning and how people use robotics. And she has a new book out called What to Expect When You're Expecting Robots: The Future of Human-Robot Collaboration. Laura will tell us more about that in a few minutes. So first, Alán is going to start off with a brief discussion of some key emerging technologies. Laura will then tell us about some of her work and her book, and then we'll have a discussion and some time for questions from all of you. Please use the chat function in Zoom to ask any questions anytime, and we'll collect them and see how many we get to. So Alán, could you start us off?
David, nice to see you, Laura. I would like to just start with a couple of remarks to think about the difference between the 21st century and the 20th century. Okay, and I argue that for us basic scientists, the 20th century was a century of discovery, whereas the 21st century is a century of solutions. It's a century where it's not only imperative to do basic science, like yesterday NASA announced that we, for example, have found water on the moon. That's a basic discovery. But at the same time, we have to take our discoveries and take them to the finish line to society. Why is that? Because we're facing several challenges. This pandemic that we're facing is an example where accelerated drug discovery, for example, by AI and automation, can make a difference in finding therapeutics or even vaccines as well. But that will pale with the problem that we're facing, which is climate change. Right? There is no comparison. Actually, I think the pandemic is just a rehearsal for what's coming. And for that, we need to use all our guns, and of course, they are political, so we need to vote. They are, action. They are changing your behavior, but also they are also our basic and applied research. So the role of academia is changing, and as a professor, I am a big advocate of doing what the engine does, which is taking your technology and accelerating it, this tough technology, and accelerating it into the market. So I'm very fortunate that the two startups that I co-founded, Zapata Computing and Robotics, have to do with the engine. They both started physically at the engine. Zapata already graduated. Robotics Lab just graduated. Robotics still has presence in the engine, but also the engine has invested in Zapata Computing. One of the themes of my research that I think is relevant to this discussion is that what we like to do, and maybe you can say, why, Alán, why are you chemists doing AI, robotics, quantum computing? Because what we're really trying to do is look at the drivers, the technological drivers of the 21st century, and see how they can change science. So, when the kids start playing video games and the GPUs came out, obviously we the scientists started taking advantage of the GPUs. Computer scientists, the AI revolution came also from this kind of commercial trend of gaming. So the World Economic Forum has come up with several trends. I'm going to mention a few relevant to this. For example, computing, communication, and storage everywhere, the Internet of Things, AI, big data, and robotics is another trend of the World Economic Forum. I added a couple in a recent paper I published, more in the materials, right? The digitalization of matter at the macroscopic to atomic scale. The precise control of molecular biology was recognized by the Nobel Prize, CRISPR. 2 years ago when I wrote this paper, I was kind of thinking this is going to happen. It just happened. Congratulations to the Jennifer Dodd and Professor Charpentier. Disruptive computing technologies such as robotics and also the imaging of matter at more and more precise scales are examples of scientific technological drivers that I added to this World Economic Forum list that I think are very important, and I think if we scientists and engineers take advantage of them, we'll transform society faster. So I think some of the topics that we can discuss here is what are the things that we need to do to translate our basic discoveries to the top tech sector. I have a couple of tips that we follow in Zapata and robotics. One of them would be finding an experienced CEO that actually helps you drive your company. Build your team with the geniuses from your lab. We had several co-founders, including myself, but also, of course, the postdoc and scientists that made the original discoveries that we built. And these two companies were built also by the amazing help of the Harvard Tech Transfer Office. And the last thing I would say, having moved from Boston to Toronto recently, is that our two companies have international presence. Okay, the United States, Canada, we're opening offices in Europe. And I think that's very important because, and also Asia, by the way, it's very important because talent is everywhere. And with this immigration situation and travel restrictions, I recommend all of the founders to start as international as possible. Those are my remarks.
Thank you, Alán. Before we get into discussion of how we turn these exciting new areas of research into technologies, which is really what I want to get into today, sort of how we do that, what are the steps we take. Before we get into that, I want to ask Laura to tell us a little bit about her work, and especially about her new book with Julie Shaw. Please, Laura.
Thank you, David. It's great to be here with you and Alán today. So last week, I guess, we launched our new book, What to Expect When You're Expecting Robots, on the future of human-robot collaboration. And in this book, what we do is we explore the challenges with the introduction of these new robotics at scale that we're beginning to see. You know, I'm working on one at Motional, an autonomous car, but we're also seeing, sidewalk delivery robots. We're seeing, sanitation robots enter our offices. So, these complex machines are entering our everyday world. And so what we explore is, what are the new challenges with this, with robotics in this, in this new domain as they move out of our factories and out of industrial applications and onto our streets and sidewalks. And we draw some of the hard-learned lessons from these industrial applications, and specifically aviation, factory robots, to help us in not having to relearn those lessons in the consumer space, but rather design systems for our everyday world the right way from the beginning. And the focus is that in order to achieve the full potential that these robotics offer us, in terms of really revolutionizing many aspects of our lives, from how we move to how we get goods delivered, it goes beyond just the technical solutions of how do you, program the robots, but it's also, it's really fundamental in how these robots behave, how they react to everyday situations, and how they, help us and accommodate us in ways that don't become a nuisance, and really help us with the task at hand. And it's also about how do we help the robots. So in order for robots to be, most effective in our world, we also have to be a little more robot compatible. So we might need to do things like have, dedicated area for robots to move around, where we're more careful than the robots are if there's a critical activity going on. So it's about, both sides of the problem. How do you design the robots to be, better, new, entities in society? And then how do you also, adapt our world to better support the robots?
Okay, thank you, Laura and Alán. Again, to the audience, we're going to take some questions in a while, so begin thinking about questions you want to ask our panelists. But I want to begin by talking about the challenges in scaling up and commercializing some of these, what we all know to be really amazing and interesting technologies. How do you transform these advances into practical, profitable, and usable technologies? You know, especially in industries, the auto industry or the chemical industry or the materials industry that are big, capital intensive, and frankly, often conservative industries. So it's a big topic, but I want to get your take on each of you. You work with different companies. How do you begin doing this? Alán, you want to go first? Your technologies are really relevant for many in the chemical industry and many material companies, among others.
Yeah, so I argue that luckily the materials and chemical industry, and to a lesser extent the pharmaceutical industry, still are in the infancy of the digital transformation and their automation transformation, right? They in one of the challenges that I pose in the article I wrote is what I like to call the matter computer. You can think of matter as registers that you can compute on and actually build new molecules. So one of the things that we work on is the self-driving laboratory, as we call it, a laboratory that not unlike Laura's robots, is a laboratory composed of automated machines that are controlled by AI, making decisions about what's the next experiment to make, in principle to do experimentation. So we found that, robotics is kind of like the CIA for that. Like we work closely in developing this type of technologies either for vertical discovery or working with partners. And some of the large corporations are actually very interested in seeing how these technologies could accelerate the discovery cycles. So I think we want these startups that many people are founding, including us. For example, Zapata Computing, a company that does quantum computing, and we want to be the software company in quantum computing in the world, right? We built Orchestra, which is kind of the operating system for quantum computers. We call it an orchestration environment, but basically it's very similar to an operating system. To be as disruptive and be the Microsoft of the future of quantum computing. Goodbye, Microsoft. And the same thing for robotics. Hopefully we are the next Dow Chemical. So I think to have that ambition and to make it happen, you have to have steps. And the companies have to start with smaller projects, and as they keep raising capital and growing, have more and more ambitious projects in terms of what materials are you tackling, what partnerships are you working on, and growing your ambitions. So you cannot start from 0 to 1,000, so you have to slowly get there.
Well, how do you get your foot in the door with a big company like Dow Chemical, which I know is a smart company, but they're a conservative company? How do you get your foot in the door?
Sorry, I just gave a talk at Dow. I don't know, this is not coordinated, people. I just gave a talk at Dow maybe, I don't know, 2 weeks ago. We're talking about how to work together, both my robotics and Dow and my lab in Dow. I mean, this is a conversation we're having. And Dow works with quantum computing companies as well, not with Zapata yet, but very soon, hopefully. So even Dow, I mean, which you mentioned is a conservative chemical company, is looking at the future. And there's always these big corporations have innovation offices. So if you're a co-founder, I think the real person you want to talk to is the CIO, innovation office, chief executive. Those are the people that I think are looking at the future, and I'm very excited to talk to you.
Interesting. But I can see, and Laura, I want to ask you the same question, but just before I leave it, I'm struck by your answer is that you're working with some of these incumbent companies. You're not trying to do it yourselves, or all of it yourselves. So there's a kind of a balance, isn't there, of how you work with some of the established companies?
I would say in our space, yes, I think we have to do both. We have to have some projects with and some internal projects.
Laura, I know you do many different things, but in your role as a CTO, you're working with auto companies, I believe. So the same question, how do you sort of collaborate with some of the bigger companies, and how do you sort of convince them of the value of the research and the technology?
Yeah, I think for me, it all starts with making sure you're solving an important problem for them. So finding either a pain point or a big market opportunity that's going to get them, excited. And how you discover that, there are many ways, but certainly, finding inroads where you can start to understand, what are big, cost areas for them, or big, again, pain points. And then, make sure that you're aligning your technology design to solve those core problems. I think with advanced systems, they're very capital intensive, and so it's important that to think about how to where to start and where you can make an impact, and kind of align your investment, your focus in that area first, and then have a vision to scale. But I think getting in and showing the possibilities, and showing the possibilities relative to a big important problem for that strategic partner is the critical step.
It's interesting you mentioned sort of that these are very capital intensive industries. So it's interesting to me how one thinks about some of these new technologies in that context. How much would it cost? I imagine they want to know, what would be my payoff?
That's right.
How long will it take to get revenues, and all those type of questions. So not
That's
much.
right.
Yeah, you find that. I guess my question there would be, as a researcher, how do you sort of make that transition from understanding and promoting the technology to understanding sort of the business needs of some of these big companies?
Yeah, I think you hit it on the head, which is that you have to think about the business aspects side by side with the technical approach. I think we often find interesting technology that might not align with business interests. And when you're talking about a big investment, you have to find the path to the payoff. It doesn't have to pay off right away, but there has to be that again, that sort of early splash where you can show the potential, even if it's in a small narrow space, and then show that path from that point to scaling up and really addressing a large, significant opportunity. So I think the business, thinking through the business side early on is really essential.
Before we leave that, I have to ask you, what are the auto companies thinking about driverless technology these days? They must be going through different periods of, first not believing it, sort of then checking it out, then working on it a little bit. But where are we at with now these days?
Yeah, that's a great question. So the industry has evolved, significantly over the last, let's say, 5 years. I think, where we are now is, it's pretty clear in the industry that it takes a few key things to really make it in autonomous driving. One is that you have to have, you have to have showcased that you have an AV software solution. So there are a lot of, R&D type demonstrations, pilots that are out there. But the second is you have to have that tight partnership with an auto manufacturer, an OEM. In our case, that's Hyundai Motor Group, who's one of our parent companies, because the changes you have to make to realize a true autonomous vehicle are further closer into the vehicle than was first expected. And the third is back to the capital intensive. You need significant capital. So I think, if you look across the autonomous vehicle industry, it takes about $1 billion to truly have the capital you need to do the testing, to do the research, to do the engineering, all the work that's needed to achieve a full solution and get it ready to, go operational.
Interesting. Alán, you must think about that question of, you're working with industries that face big capital investments to make some of this stuff happen. How do you convince a chemical company to spend $1 billion on a new chemical plant, or $100 million on a new chemical plant? It must be a tough sell.
It is. I mean, having said so, there are ways, touching base on what Laura says, is looking where the value is going to be. Let's talk about energy and let's talk about discovery, right? I mean, about 5 years ago, I was lucky to work with Roy Gordon and Mike Aziz at Harvard in discovering an organic molecule called to store energy. It's called, now it's an entire field called organic flow batteries. Instead of using metals in batteries, you put a big water tank and you throw a molecule, right? And the question is, which molecule is going to be the one that is the cheapest to store back and forth electrons, right, for a long time? You need two types, one for one tank and one for the other. Like batteries always have two chemistries, right, to load electrons on one side and pull them to the other. So it's been a kind of 5-year journey of collaborating with them. And we finally have the molecules. And then the question is, okay, exactly that one. Where are we going to make them? And they're similar to the dyes that you have in your genes. Okay, like ink. And you know, early on, Germany, for example, was the leader on printing dyes. Then, of course, there was chemical industry like that in the United States. Now all of it's in Asia. And the question is, where can you scale this up? Where are the places in the world where you can do this without damaging the environment? You're going to try to save the world by storing its energy renewably, right? The question is, where are you going to do the petrochemistry necessary, right? So these are, I think, some of those huge challenges of the 21st century. And I think connecting to what Marina Mazzucato might have talked about, I was having lunch, so I couldn't listen to her, but she writes a lot about the role of the state. And I think this is where I'm happy to be in a country like Canada that thinks about its future with state interventions that will make us renewable, right? That's the plan. Let's see how far Canada gets to. But one of the reasons of me moving here is that there is so a roadmap for doing them. And there, for example, you will need a lot of state intervention, right? We have to kind of help the development of these new technologies. So it's not only the industries, you might need to have some incentives. I think it's going to be, if you really want to get to that scale of producing molecules for storing all the energy of the world, this is going to be like a Manhattan Project scale project. Also billions, like Laura said.
I'm curious about sort of personal stories too, as sort of researchers and scientists. You sort of, you know, you're very accomplished in what you've done. And I imagine it's easy to get absorbed by solving big technical problems. I know both of you have done that. And, you know, so I guess the question is, how do you sort of do both? Focus on solving the big technical problems and also focused on the bigger, what we're talking about, scaling up, commercializing, working with companies. Is it sort of a personal challenge to sort of do both? Either one. Laura, you want to take that?
Sure. Yeah, absolutely. It's a constant challenge. I think with every phase of growth, you have to re-examine your style, your leadership style, how you're spending your time. If you're going to work on a technical, dive deep into a technical challenge, being strategic about which challenge you focus on versus, which you have others focus on. So a lot of it's about, building the right team and again, evolving, that team as you go. For me, it's always important to have a few like really strong scientists or engineers who report directly to me. Even though I have a very large engineering team, I like to have a few individual contributors who continue to report to me. So through them, I can continue doing the research and engineering work that I think is most strategic and most critical for success. But yeah, as I think, again, as your team grows, and we're getting close to about 500 engineers right now, as that team grows, you have to, think about different models that are going to work to allow you to stay close to the technology areas that are most important, but also to allow your team to go off and effectively solve those challenges. I think of my engineering team as very much a system of people, and how you set them up, what how you construct the way they focus on and choose between priorities and projects, what kinds of input you have. All of that is kind of like designing a system, a system that's going to produce a system, and it needs just as much thought and care as the system design itself.
Right. Tricky, but you yourself need to sort of stay in touch with the most cutting edge of the technologies, I imagine.
Yeah, absolutely. Again, you have to find ways to stay connected, certainly. And for me, that means, finding those areas where there are still unsolved problems and making sure that, I'm having input in those areas. But because you can't stay involved in all of it. So you have to, sort of pick, again, where you focus your time and your energy.
Alán, you're an amazing scientist, I know. You've been very accomplished. And if the audience is not familiar, it's worth checking out some of Alán's research and some of his papers and projects, because they really are sort of the cutting edge of chemistry and material science. So then the question is, you go from that to talking to Dow Chemical, to starting up companies. Is there a different mindset, and how do you kind of switch back and forth?
Yeah, it's very challenging, and I have to say, I personally dropped many balls. So I don't know how many emails I don't answer, how many things I miss as opportunities because I am focusing, as Laura says, on the important things. To me, as an active professor, I think one of the most important things is to have a dynamic team, and I like to call it an anarchist collective, right? I mean, a set of very smart, multidisciplinary people whose mission is to be bold and discover things and have fun, right? So that's my academic side. And then the entrepreneurial side, let me go back to the recommendations, right? I mean, I decided that, to talk to my team with some of my best quantum computing people, for example, in Zapata Computing. And we decided to get together. I still remember that meeting in Qdoba in Cambridge, Massachusetts, eating burritos like this. And decided we're going to start a company. And we called our friend Christopher Savoy, that, was switching companies, and said, come over, we're going to start a company. And, that is amazing because you provide an opportunity to your team to transition. And many of my current graduate students go and do internships. And that allows kind of like the research that you had to leave and to give new job opportunities to your team. And we did the same with robotics, exactly the same thing. I think we also had so many burritos in Qdoba. And I think that's what I try to encourage more of my colleagues when they tell me I have a technology. As a professor, I think if you don't do that, then you might have a problem. So another thing I want to just mention as an advertisement slash interesting thing is check out people. They created the Structural Labs, started at the University of Toronto, but now it's a very global initiative with more than 17 sites, I think. 17 tracks in several sites around the world, including Oxford and Vancouver and Toronto and Montreal and many places in the world. And what the CDL does is, without any fees or anything, incubates these companies, and we just created the Matter track, a track for materials companies. The quantum computing track at the CDL has been responsible for Toronto having the largest number of quantum computing startups per capita, I guess, in the world. So these kind of academic government initiatives actually do help the ecosystem. So, but going back to the question of how I do it, I don't know. You just have to juggle all the things at once and throw many balls and just take it day by day. But I think Laura's advice is very resonant with me. You have to stay close to the matter in a couple of things. You have to know how to delegate, and you have to have a very dynamic and smart team.
And I imagine, or I might hope, at least in an academic setting, the work you do with the startups and the business community helps you focus your lab, or helps the people working in your lab sort of think about problems that they should be working on.
Yeah, this morning I started my morning with a call with Tata Steel. So Tata in India founded, and by the way, very long, I also talk to Tata, but Tata Steel funded our research on this ChemOS, a software that we use to make self-driving laboratories. That's the initial funding of one of the fundamental pieces of software we developed in the lab. And we're talking to them about how to coat steel. I didn't know anything about coating steel, but it allows my people to be exposed to real problems and puts them in a new creative spot where now that we have to reimagine how to coat steel and how to discover new steel coatings faster than all the people in the planet. So that's an example where I never imagined in my life when I started doing quantum chemistry I was going to be thinking about coating steel, but it's quite fun.
Yeah, interesting. While we're thinking about the lab, I was struck, Laura, you're talking about how people work with robots and how you've looked at that a lot. And Alán, I know you've done a lot of automation and use of robots, or pioneering use of robots in the chemistry lab. I was just struck by that overlap of the issue of how people work with robots. So as material chemists, what's the issues? And maybe Laura, you might have some thoughts of how people can better, including scientists, better work with robots. Alán, you want to tell us your experience so far with, when I visited you a few years ago, you were just literally unpacking a robot and beginning to use it in your lab. What's been your experience?
Well, I have to report that actually the robot is actually now doing chemistry and is trying to design the next generation display molecules in a collaboration funded by DARPA. But I'm gonna break all the rules here and share my screen because I want to show something to Laura. I can't. Okay, so let me tell you what it is. They disabled my sharing screen. I mean, they knew I was going to hijack the computer. But one cool thing that we did and related to Laura's research is we started thinking exactly about what she's talking about. A robot walking in the lab, inspired by my friend Andy Cooper in the UK. He also has on them, right? But robots walking in the lab doing things. But when this robot has a coordinate system, it doesn't see anything. So we just published a paper where our postdoc of mine that used to work in the self-driving company in Israel, actually, moved to my lab, left self-driving car company, now he's doing chemistry. And we did the first data set in computer vision system for detecting flammware and chemicals. And I was going to show you a YouTube video of a woman doing chemistry, kitchen chemistry, and we detecting the flasks, what is a liquid, what is a solid, what is a powder, what is a foam, right? Which allows us, of course, to imagine the future of where Laura and I will collaborate and maybe we'll find a company together of these walking robots that are next to you doing chemical experiments, and you have to be very careful not to run into them and all the things that missing things that she talked about.
Laura, I'm curious your thoughts.
Yeah, absolutely, Alán. That's a great, I love the visual effects, especially. A great example. I think, one of the big differences in kind of, robots that we use in, whether it's in a lab setting or in a factory or in, again, the aircraft that we ride in commercially, is today those robots are used by people who are experts on the robots. So, in that case, I'm sure in your lab, Alán, there were many hours spent, learning about the robot, understanding its capabilities. It sounds like you even, were programming the robot to detect objects, in its environment. Everyday users aren't going to have that same intimate knowledge of what the robot can do, and more importantly, like what the robot can't do. So that's, I think one of the big challenges is how do we, again, start to develop ways for these automated systems to communicate in ways that are going to be more natural, more intuitive for all of us as we're crossing the road in front of an autonomous car or grabbing our pizza from the delivery robot at our doorstep. We don't want to have to know what the robot's doing and what it's thinking about and how it's, where it came from. But we do need to know how to interact with it and how, safe ways to engage with it. And we don't want it to burden us or get in our way or, trip us as we're trying to cross the sidewalk. So, these are some of I think the new challenges. And And we have seen some of this if you look at how automation has been developed in cockpits. We've had to design, the automated flight systems in a way that can collaborate with a pilot. And that teaming of people with complex automation has been, sort of well studied in ways that you can support a person. It's not always obvious. It's not just about usability and kind of making the systems enjoyable to use or delightful. It's also about the decision making of the person who's going to interact with that robot, and how do you again help position them to make the best decision and take the best action in those interactions. So it may not actually be the most ideal, delightful, entertaining experience, but if it works well, then that's likely to be much more successful long term. Than just focusing in on some of that sort of entertainment aspect of these robots. So we think that that's really where we encourage the technology community to kind of focus on next generation robots, is how to enable them to behave in ways that help support the people that they have to interact with.
That's really interesting. I can imagine the work going on for example, on the factory floor, to allow a worker to safely work next to a robot and not have to train the robot on every time, but to take instructions from the human worker and safely work together is a difficult problem, isn't it?
It is, and that's actually not how robots in manufacturing settings work today. Today, the tasks between people and robots are mostly decoupled. We've moved most of those robots in factories out of the fenced-in areas where they started. They now, in some cases, are co-located with the human workers, but they still usually are working on separate tasks. There tends to be very little collaboration today. So that's kind of where a lot of research and development is focused. We see a number of companies working on that, but that's kind of an evolutionary step in robotics, both in factory settings as well as consumer environments.
So we have some questions from the audience, but I have one more I want to get in before we turn to those questions. And I want to talk about sort of the right combination of funding from VCs, from private investors, from the government, and how that should work together. In particular, the role of the government. We heard from Mariana Mazzucato earlier, or right before this session, on sort of the importance of government support for technologies and driving the direction of innovation. So how do you think about that? And one thing I was curious about, Alán, I believe you've worked with the Vector Institute. And I think my understanding, they've done a pretty nice job of getting the public sector involved, along with private companies, investment, along with universities. So maybe let's start there. Is that a good model, or what do you think works in supporting this type of technology?
Absolutely. Something that I learned when I moved to Canada is a word that we didn't use that much in the United States, and they call it leveraging. Okay, I found it pretty Canadian, or at least pretty Torontonian. Okay, so it looks like everything is a stone pot or soup, right? So if the government is going to give you $10 million, then you can go to industry and match it with $10 million, and then the province will give you $10 million, and everything seems to be kind of built in that kind of model here, or at least many science efforts. Whereas in the US, I noticed that sometimes that was not the case, and things were more directly funded. Like, for example, these large-scale Department of Energy efforts, like the National Labs, or like the large-scale, other efforts, like DoD efforts, etc. So that is kind of an underlying model of the Vector Institute. In the Vector Institute, the founding story was the tech talent of Canada was having like a brain drain. How to reverse that? It was a combination of the genius of Jordan Jacobs, Ed Clark, several other visionaries that said, let's start calling the companies and say, let's put some money here, right? Let's just show off the AI talent in Canada, built around Jeff Hinton. And like, let's just make sure that we have the investment of companies and banks, for example, and all types of institutions, as well as the province and the government, and start funding this initiative, right? So it was starting at the time I moved here. Went to a beautiful room in the Mars building, where now it's full of researchers. At the time I went there was empty, and it's full of 150, even more AI researchers from all over the world. I mean, we have no visa problems here, so pretty much people from all over the planet are there doing amazing AI research. And I've been telling Canada, you should have a vector institute built every year on a different subject. That type of investment should be happening every year in a particular situation. For example, AI for self-driving, etc. But this vector has attracted a lot of innovation. I don't think it's a surprise that vector faculty members, for example, Raquel Urtasun leads the Uber AI self-driving cars lab, just to connect to self-driving cars. There's also an NVIDIA lab led by another one of my colleagues that works in computer vision. She's amazing as well. There's a Samsung AI lab also led by another one of our colleagues. And that is not a surprise, right? I mean, it means the corporate is also multi-trillion, and you have this positive building of an ecosystem. I like to make an analogy to what the Broad Institute did in the Boston and Cambridge area for biotech, right? So there are some public-private investments that can really make a difference. Last comment I will say about that funding. Canada, for example, needs something like a DARPA. Big discussion. I mean, DARPA has funded my lab even here in Canada since I started it in the US. DARPA is basically one of my bloodlines. ARPA-E funded our battery work when ARPA-E was full in previous administration. You want to think about this type of organizations like DARPA and ARPA-E as critical to the tech of the future.
Yeah, I think the key to one thing to keep in mind is not just the importance of government support in advancing the technology, but the importance of that support in growing the economy, that this has a long-term impact in helping the economy grow, this type of support. But Laura, I want to ask you, I think you probably have a somewhat different perspective, given where you're working right now, but sort of how do you see the right combination of government involvement with a private company, but how can the government support and facilitate these technologies?
Yeah, so I spent a good part of my career at Draper Laboratory, where my team there was funded by DARPA, IARPA, other government groups, and also in autonomous driving. The DARPA Grand Challenge is where the technology really kind of got off the ground, and many companies still stem from that original effort that was funded primarily by DARPA. So I think it does have a role, absolutely, especially in investing in earlier stage technology where it's not to the point maybe where there's a clear near-term private avenue or in partnership. And I think what's important is to think about how to try to align interests. So when you have a government funding avenue, think about kind of what are their interests. So we talked about kind of growing the local economy, preserving talent in the area. Also, maybe they have a different, totally different application that they want to make progress in one area that might help in another area. And so try to align those interests with some of the private investment avenues so that you can try to get the best across both. I think that's one of the key ways to kind of leverage that without otherwise you can become distracted. I think it's easy to, focus in on any one of those and end up with a whole bunch of projects that are only loosely coupled. But finding a way to bring that funding together to focus on, a central objective is the critical part of making the most of those multiple funding paths.
Right. Yeah, I think we sometimes forget how important DARPA was in sort of really getting the whole driverless autonomous car research going, and for years sort of keeping it going as it was sort of making slow but not amazing progress, and then suddenly it kind of blossomed.
That's right.
let's take some questions from the audience. And I'm just going to read them and see if we can see what the make sense of them. Someone wants to know, how do you navigate the intersection points of long-term technology roadmap, sort of long-term roadmap, the architectural decisions of a complex system, and value delivery to society and customers? So I guess this question is really getting at, how do you think about the long-term plans and solving long-term problems? Go ahead, Alán.
I'm going to give a very brief example because it's the top of my head. So this is one of the projects at Zapata Computing. There is this very large company. I cannot tell you which one it is, but a huge company. We're going to reveal at Q2B, I think, in December, which one it is. That is looking in the future and saying, well, we have this complex computing problem, right? And we know quantum computers are not there yet. But what we need is a workflow that uses quantum-inspired algorithms, right, in the right places, in production, in computing, like the day-to-day operations of this very, very large corporation. This is a logistics problem. And we're building, in Zapata, we're using our orchestra system to actually build the entire workflow for them. And there is this couple pieces, but let's say one of them, primarily, that we know when a quantum computer is big and Chilano enough, it just doesn't fit them. So I love the thinking of this company, right? They're spending some investment right now. They know the quantum computer will help them eventually. We don't know if it's going to be 10, 20 years from now or 5, depending on the quantum computing industry, right? But they're already engaging people like us to say, no problem, our workflow is ready. The second we can plug in the quantum technology. And even with classical technology, just by revealing this workflow, we're already helping people, right? There's already improvements just by thinking about the future. I think that's what you want to think in these long-term technologies, right? Like, I agree, mine is the same thing Laura might say about self-driving and things like that. What are the minor things? Like I noticed, of course, there's no self-driving cars, but when I use my car or a car rental, there's all this driver documentation that already happens, right? Or self-driving robotics in general, right? Like there's all these things that are helping me all the time, And that kind of like is a step forward, right? So it's kind of the same thing I think in our quantum computation and workflow. It's kind of like something that the company is thinking about the future and is engaging us to do, and I think it's a cool project.
But companies have to sort of begin getting familiar with the technology long before it sort of solves their problem, is part of what I'm hearing from you saying.
But these big companies also think about, okay, 10, 15 years from now, 5 to 10, whatever is the right moment, when the quantum computer breaks the bank, I'm ready day one, right? With the workflow,
right?
That you have to think like that.
Right. Again, Laura, you're working on sort of a long-term problem, as I see it. Different stages of driverless technology. How do you think about that long-term roadmap?
Yeah, I think, and what Alán said really resonated with me as well, that I think, it's important to have the big vision. Where do you ultimately want to go? And what do you think is a path to get there? But then you have to think near term. What can I do over the next 1 year, 2 years to show progress, demonstrate progress, solve an early pain point, which will inevitably only be a partial solution to that big, vision that you have that might take 10 years to get to. But without having that near-term step to, again, solve an early pain point for a customer so that you get them engaged or demonstrate key progress for that next investment. Those are, you have to couple those two together. And I think the question also included the architecture, also designing the architecture. And I think that's a key part of achieving that, because you want to have an architecture that can set you up to scale and to grow towards that bigger vision, while only populating it for that nearer term problem. So I think, it's important, again, coming back to that idea of sort of conserving capital and making sure that you're applying it in the right ways. So, focusing what part of the architecture you work on first to, again, have an early win, while also, not locking yourself in so that you can now expand the solution longer term.
Interesting. A lot of strategic planning is what I'm hearing.
Absolutely. And constantly rethinking the strategic plan.
Adopting as the technology.
That's right.
Or doesn't progress.
That's right, because in our areas, you learn as you go. You're gonna, what we expect day one. You constantly are learning and have to pivot that strategy and refine it, as you learn, and be ready to completely recreate it as you need to. If you get some new key insight that changes what you were expecting. I think that's really important in these complex systems.
Right. Alán, I think this one is mainly for you. The question is, where are the intersection points between quantum computing and AI? And where do you think those two technologies will cross paths? And what problems will they work together? So I can't imagine a more perfect question for you, really.
Yeah, so as you notice, I have I work in a quantum computing company and also an AI for chemistry company. I always tell the two CEOs, you have to buy the other company and see who wins. Or you merge or something, right? But let's talk about the near future. Quantum and AI, of course, two hot topics. If you go to the archive preprint server and you Google quantum machine learning, specifically the machine learning piece of AI, you will find hundreds of papers, right? They all are based on, most of them are based on variational algorithms, an area, by the way, just bragging that we were one of the ones that introduced variational algorithms. And now these variational algorithms are used for a lot of machine learning applications. It's a very controversial topic because there are very few formal results of when will a quantum computer help you with AI. There's a lot of algorithms out there. I'm a big believer that obviously one of the obvious questions is when you have quantum data stemming from a quantum simulation, quantum AI is the only way to treat it pretty much effectively, because the quantum data is so large that doing AI on it. But on the other hand, classical data, right? You want to use models that do not require showing the quantum computer a lot of data, but rather generative models. So the area of generative models, where you have an underlying quantum distribution that generates data, is very promising. There's no formal results that this is going to be better. But again, stay tuned for the Q2B conference. The Paracomputing is going to show you something really cool about that. So yeah, everybody has to register. But it's still even that result, it doesn't have formal proofs. But check it out. I can't wait till December.
And how much, I'm curious, I know you're focused on one thing you're focused on is new clean materials, clean tech materials. So does it, in a way, are you just willing to think whatever tools I need to create the type of materials I want, I'm open to different methods?
Funny, just today I had a call with another company and they told me, Alán, do you want to help us with COVID? We have this synthesis pathway problem, and can you, with your AI and robots, help us? The answer was like, yes, okay, COVID, yes, right? I think that's what we need to do also for climate change, right? I mean, it's not the one person who save the planet, it's all of us together making these little chips. It's almost like a big stone, and we're chipping there with a little hammer there, right? So even though it sounds very powerful, really, it feels like you're just doing like this little piece of the puzzle, right? So that's what I started the remark saying. All of us scientists need to go there, and companies, but also academia, think about ways to make things better. For example, a basic discovery, the perovskite solar cells, sounded like very fundamental science. Now they are the top performing materials, potentially commercializable really soon, right? So that was a fantastic revolution over the last decade or so, since they're nothing to perovskite solar cells. We just have about room temperatures of superconductors at pressure, right? There's all sorts of materials, topological insulators, all sorts of materials discoveries that could revolutionize computing or technology or energy, that I think society needs to pay attention to and build an ecosystem where the VC structure, the government structure, everything is helping these companies that are not as traditional as your typical app company that is making a new thing to take selfies and thrive. And that's what the engine is about, going back to this conference, right? This is all about what we're here, how to make these companies that are kind of the oddballs, but the real ones that will change the planet and thrive.
I have another question. I think, Laura, it might be most relevant for you. It asks, how do you drive public adoption in fields that the public may not understand?
Yeah,
so, I'm sure there's a lot of public misunderstanding or just not understanding of what driverless car technology is and will be.
That's right. We actually recently conducted a survey to try to understand that problem. And what we found was that the more knowledgeable people were about self-driving cars, the more enthusiastic they were about those systems, entering their environment and them, starting to use the technology. And so, for us, that's a part of when I talk about strategies or the long term and the near term, part of the near term strategy for autonomous cars is to get it out into the public. So, we have an operation in Las Vegas where, you can use your Lyft app and you can hail a self-driving car. Now, because the technology is not all the way there yet, it has a safety operator there supervising the autonomous system, but it still allows, the public, the general public, to get more exposed to the technology, so that it's not just not here one day and then here the next, but there's a progression, and you allow people to see it as it's building up. So for us, that's a big part of it, is the education, the exposure of the public to the new technology.
We just have a few minutes left. I wanted to ask you sort of each an open-ended question. If you're speaking to this audience that is interested in entrepreneurship, investment, where technology is going, give me your short summary of what they should be thinking about. Are there any sort of key technologies that people aren't thinking about, or how should they be thinking? What would be your message to this audience? Alán, you want to go first?
Okay, so I'm going to start from the academic perspective, right? All of academics are kind of trained to become their advisor. You don't want to become your advisor. You have to be the rebel that moves out of what your comfort zone is, and all the time. And I pledge that I always try to be moving out of my comfort zone to things like coating steel, all the way down to quantum. And I don't know everything. I am like, the least knowledgeable person in my lab of many topics, because it's very shallow and broad compared to many of my deep, super amazing geniuses that we have there. What I think is something I've learned that it has driven me far. So for all those scientists and young people in the audience, it's fine that you start with one topic, move to the next one, move to the next one. You only live once after all. And I recommend them to kind of look for those opportunities. For example, the intersection of cryptography and material science is, for example, an interesting thing to look at. As an example, you look at the matrix of interesting technologies that are coming up, right? And you look at the problems that society has. See this matrix, some holes that you could fill, and maybe just go to one of these incubators and come up with an idea, and have the incubator help you convert it into a company. There is a lot of capital in the world that wants to deploy itself into good ideas. There's a bunch of crap ideas out there too. So the question is, how can you transform your idea that is hopefully good as you refine it into something concrete for society? So that's the challenge of top technology. And I think from the academic perspective, I think that's very important. So for the young entrepreneurs to know this happens. Last thing I would say, if you're a graduate student or a postdoc or an undergrad, seek internships in industry, and also have advisors that allow you to do so. Some of the amazing things that happen in my lab is a student goes to industry, they learn something really new there, they publish or whatever with the industry host, and I don't have to be involved or whatever, but when they come back, we learn new things and we do it. So don't underestimate all the cool stuff that's happening in industry. And I would say that would be my view from the academic perspective.
Laura, I'm told we only have 1 or 2 minutes left.
Yes.
But sort of your message to this audience.
Yeah, I'll keep it short. I mean, I think I really resonate with what Alán was describing. And I think if I could add one thing to it, it would be to follow your passion. Try to align your own personal passion with a problem that matters. When you do that, magic happens. You can find investment, you can find customers. But if you have those two things and you're able to bring them together, good things will happen.
That's great. There's no shortage of great technologies, and there's no shortage of important problems to solve. So I think that's what my message, if anything, today is. Thank you both so much. It's really an inspiring conversation, especially thinking about all these amazing technologies and their relevance for the problems that we care about. So thank you both.
Thank you.
Up next, we have a 15-minute break followed by a fireside chat with Matt Rogers. Thank you again, everyone, for participating in this session, and thanks Laura and Alán, and see you all after the break. Thanks, everyone.